Hi everyone, we from Broadcom are here to present our hackathon idea Spec Conformance Test. Let's start with the problem statement. There is a need today for a conformance test infra which can facilitate seamless integration with SONiC. It should be able to identify regression issues before integration, must be vendor neutral, and must help onboard a new silicon vendor seamlessly. The solution that we are proposing is a test infrastructure which is Spec driven. The solution is vendor agnostic, and the infra adapts to any change in the Spec automatically. It allows for extensive API testing with all possible attribute values and types. It is future proof. Objects or attributes not exercised by SONiC today also can be validated. The implementation is generic and avoids any generation of test code. PTF today covers functional aspects, while this solution will be covering the API syntax. The test infra that we're proposing here uses metadata. So metadata is a set of auto-generated data and functions from headers, and this is basically ANSI C source and header, which is available as a shared library. There are multiple tools today that use metadata. We are introducing a new tool, Spec Confirm Test, which will validate a libsci implementation against the specification. The test infra will exercise CRUD APIs and capture the results in a JSON report. All the attribute value combinations will get exercised along with the scale for the given objects and attributes. The infra will identify list of objects and attributes that are supported by a implementation, and it will validate attribute property conformance to the specification. A report generated by this infra can be used to generate customer-facing documentation, identify any breakages during CI, and automate coverage tests. The executable is a CPP-based executable which will link with library and can be run on a switch. It will typically be run in the syncd Docker after stopping the syncd process. It will exercise CRUD APIs with various values for the attributes. The test can be done for a single object or all supported object types. The infra understands attribute flags like mandatory on create only, etc. Attribute values will be chosen based upon the attribute data type. Hard-coded default values can be overridden by the user using a configuration file. The infra is also capable of identifying object dependency maps, and it will create the dependent objects with mandatory attributes with default values. Such dependent objects that are created can be reused by saving them in an object pool. It can also skip over invalid attribute value combinations. This is an example of a spec that is used to generate the metadata. So as you can see, the spec already has information about the input-output parameters and the attributes and the data types of the attributes. This is the architecture of the spec conformance test tool. The spec conformance test tool will be run on the switch directly, and the user provides input to the spec confirm test using the command line arguments or the config file. And user input is provided to the spec confirm test, which will be saved in the database. And this data will be used in conjunction with the metadata to determine the attribute test values. Once the test values are generated for each of the attributes and objects, the tool will go ahead and execute the CRUD APIs with the given attribute values that were determined beforehand and generate a JSON report of all the tests done for the object. Let's now look at a short demo. So here I have copied over the spec confirm test tool into the syncd Docker and stopped the syncd process. I'll be running the spec confirm test tool with the command line argument indicating it to run tests on only one object, which is object type virtual router. To keep things simple, we have pre-selected a couple of tests that we will run and showcase here. So let's get started. As you can see, the test is completed, let's look at the results now. So the JSON report that is generated by this tool will contain the spec versions and the metadata versions, and then it will get down to listing out the object that was under test, and if there are more, then you will see more entries here. Then it will start listing each test that was executed on the object. So here the first test that was executed was the default value test, where we were cross-verifying from the size specification if the default value mentioned in the size specification for a given attribute is the one that the SAI implementation has initialized it with. So here we do a get API call on the SAI implementation for this attribute to cross-verify if it is initialized with the right default value. So as you can see, the first entry here is the attribute name. The second entry is the default value that we have read from the SAI specification. The third value is the value that we got via the get API. And the last one, which is the get RC, indicates the return code of the get API. So here everything looks good because the return value of the get API syncs with the default value, which means that the libSAI implementation is initializing the attribute to the right default value. The next test that was executed is a set get test. So in this case, for a given attribute, we will set a certain value for that attribute and then get that back using the get API. And the report also indicates what was the return code returned by the library for the set call as well as the get call. So by looking at these values, you can figure out if there is a discrepancy in the data that you are expecting to see. So in this particular case, as you can see, for the admin v4 state, we tried to exercise the set with all possible values of the attribute. The attribute here is of type Boolean. So we tried with a value true and as well as with a value false. So for example, if the attribute is of type enum, we will run through every possible entry or every possible enum option that can be programmed for this particular attribute. So in this particular case, when we program the value as true, the return code for the set API said not implemented. So basically this libSAI implementation does not support a set on this particular attribute. Now let's look at a case where we should be able to figure out, or we can figure out a discrepancy in the SAI implementation. In this particular test, for source MAC address, we are setting the MAC to all zeros. So the expectation would be that the libSAI implementation would return an error, right? But in this particular case, we see that the set API, execution succeeded with SAI status success. And the get automatically obviously was successful as well with a SAI status success. Now, if you have a tool which is built upon this report, which can parse this report in conjunction with the SAI specification, it is very easy to see how this tool will really help in identifying, regressions. So the tool can really parse this report and flag off any issues that you see from the SAI implementation. So this is one example of how this report can be used. And then the last test that we executed on this particular object was a create remove test. Here, this particular object does not have any mandatory on create attributes. So it was a plain creation and deletion of the object. And the report also tells you what was the average time in milliseconds that the implementation of the SAI took to create and remove an object of this type. So this is how we think, this tool will really help in finding regressions and validating the SAI implementation against the specification. Thank you.